Any questions from 6.1? No? Okay, I mean, that's great. If not, I'm going to get rocking and rolling on 6.3. So 6.3 is on simplifying complex fractions. So a complex fraction is just a fraction within a fraction. Okay, like a basic example of this, let me get to the right part of the book. Hold on. A basic example would be something like, 3/4 divided by 2/5. Okay, 3/4 divided by 2/5 would be a basic example of a complex fraction because we have fractions inside of fractions. Okay, and there's really two main ways to simplify these, which we're going to go over. Actually, I'm going to stick to one because I found out that one way is just kind of easier because it works better for all of them. The other one is like works well in certain situations, but the one I go over just works well for all types of complex fractions. So the way I'm going to go over this is actually, it's called multiplying the greatest common or least common denominator. So least common denominator method is what I'll call it, okay, to simplifying these complex fractions. So the way you do that actually is you get the least common denominator from all the denominators, okay? So like right now here, let's use some other colors. We've got two fractions going on, right? You guys see that? And each of those fractions has two denominators, or really each fraction has one denominator, but we've got two denominators right there in the blue bubbles, the 4 and the 5. So if we're going to find the least common denominator for 4 and 5, the easiest way to do, actually, it might not be the least, but it's just the easiest, is to multiply them, right? 4 times 5, so 20. 20 is going to be our least common denominator. And all we really need is a common denominator, okay? But it's our common denominator for both. So I'm going to rewrite this without all the colors. And what you have to do with that least common denominator is actually multiply it to every numerator, okay? All the numerators. So for here, we've got a 3 times 20 and a 2 times 20. What you're really doing is multiplying the same thing in the numerator, the big numerator, and the big denominator. So you're just multiplying by 1. But when you do this, it'll get rid of the fractions within the fraction, okay? So I'm going to do this like kind of long-wise. 3 times 20 is 60 divided by 4. 2 times 20 is 40 divided by 5. And what happens when you do that, these will cancel. 60 divided by 4 is 15. 40 divided by 5 is 8, right? And we're done, okay? Now, that's with numbers. I mean, we're going to introduce letters, of course, because that's how we're an algebra course. But that's kind of the basics of this. So if I looked at another one, and I'm going to just stick with numbers for now. If I looked at another one that was like 1/2 plus 3 all over, let's say 2/5. There's just another example, just to kind of hammer in the example aspect. Now, look, we've got a complex fraction, right? Because we have fractions inside of fractions, okay? You got the big fraction bar, and then you've got the two little fractions. So I'm going to think of this as, this 3 actually as a fraction as well. So I'm going to rewrite this. I'm going to say it's 1/2 plus 3 over 1 over 2/5. And then I'm going to look at all three denominators. 2, 1, and 5, okay? 2, 1, and 5. And I'm going to think, well, what's the least common denominator? What's the least common multiple, right, of 2, 5, and 1? Well, it's going to be 10, right? The least common denominator is going to be 10. 10's divisible by 2, by 5, and by 1. That's really where it comes from, okay? Like that 20 is divisible by 4 and also by 5. That's where it's coming from. So I'm going to multiply this 10 to each numerator. okay? And when I do that, I'm going to kind of make this smaller because I'm going to run out of room here. I'd have 10 divided by 2 plus 30 divided by 1 all over 20 divided by 5. And notice each one of those divides, right? 10 divided by 2 is 5. 30 divided by 1 is 30. 20 divided by 5 is 4. So we wind up with, add the numerators because that's a grouping, 35 fourths. And we're done. So we went from a complex fraction to a non-complex fraction, if you want to call it that. Okay? Any questions? Any comments? Any concerns? Other than, oh, we're about to put in numbers or letters in there, it's going to make it harder. I don't necessarily think it's harder. It's just going to look more complex. No pun intended, okay? These are complex fractions. But it's going to look more complex with letters compared to just numbers. Hold on, guys. Give me just 1 second. Okay, there we go. Okay. So let's keep moving forward here. So let's look at one that just has variables. Let's say, or I mean, I say variables, let's say variable denominators. Let's say 2 over x, let's say divided by 5 over x squared, okay? 2 over x divided by 5 over x squared. So again, I'm going to focus on the denominators. We got an x, we got a 2, right? And I'm going to think, well, what's the least common denominator? Okay, guys, what's nice about variables is you always just take the larger exponent variable, okay? If they're the same, we'll do some here in a minute that aren't the same. If they're the same, all you have to do is use the one with the larger exponent for the least common denominator. So the least common denominator for these two is just going to be x squared, okay? If this was like x to the 5th over x to the 20th, you'd use the x to the 20th, okay? You're going to use the larger of the two variables if they're the common. We'll do one that's not common here in a minute. So I'm going to do the same thing again. I'm going to multiply that least common denominator on the numerators. It's got to go to all the numerators. So we wind up with 2x squared over x, right, for the numerator, because we multiply the x squared in, all over 5x squared divided by x squared. Okay, 5x squared divided by x squared. And what happens is the x squared and the x cancel, right? If we look at just this numerator from a simplification standpoint, this x would go away and it would leave us with the x in the numerator. In the denominator, this x squared would cancel with that x squared. So we're left with 2x over 5. And notice all the fractions inside the fractions have gone away. Okay, they're all vamos. Okay. Questions? I'm kind of spoon feeding it a little bit, like I'm slowly stepping into the harder stuff. Like if you have the book open and you're looking at it, you're probably going, oh my God, what the heck? Okay. Okay, so let's go on. What if we have two variables? Let's say we had 3 over, actually let's do 3 plus 1 over x all over 4 over y, okay? 3 plus 1 over x all over 4y. Okay, so the first thing I'm going to do is write these all as fractions. Look, this is just an integer, so we can write it as 3 over 1 plus 1 over x all over 4 over y. Okay, if you're going to use this technique, which if you don't know how to simplify complex, I'm assuming you're going to use this technique. If you're going to use this technique, you're going to have to think of all of these as fractions. Every term in here is a fraction, even if it's not written as one to begin with. So then I'm going to look at the 1, the x, and the y here. Now notice, these are different variables, so it's not like we could just say x or y. So the easiest way to get an LCD is really just multiply everything if it's different. 1 times x times y. So that's just xy, okay? That's going to be our LCD. Now think about this. So I'm going to kind of think forward a little bit. If you've got xy, it's going to divide out the x here. So that'll get rid of that fraction. It's going to divide out the y here. So it'll get rid of that denominator, I guess you can say. The 1 I'm not worried about. It'll just be 3xy up there. Anything divided by 1 is itself. So I think this is going to work. So I'm going to multiply xy to each one of these, okay, to each numerator. This first fraction, yeah, it's going to be 3xy divided by 1. That's just 3xy, okay? The next fraction is going to be xy over x. The bottom fraction is going to be 4xy divided by y. And it happens. These denominators are going to cancel out with part of what we multiplied through. Okay? And that leaves us with 3xy plus y all over 4x. And I know what you're thinking. You're thinking, hey, wait a minute, there's 2 y's up here. Can't we factor that out? You're more than welcome to factor that out. If we factored the y out, we'd be left with 3x plus 1 all over 4x. Now notice these don't cancel, right? The y, the 3x plus 1, and the 4 and the x, there's no common factors. So I would accept, and I think the book also accepts, either one of these as answers. We'll see once we get in here. It factors them completely at the end. So the book's answer is going to look like this one because it's going to factor, if it can be factored at the very end, it's going to factor it at the very end. Okay. Guys, are there any questions before I start rocking and rolling? Okay. So let's combine letters and numbers. Let's say I've got, let me think. Say I've got 4y over 3 divided by z over x. That sounds good. 4y over 3 divided by z over x. So this is the first one I believe that we've got letters and numbers in the denominator, which is fine. We're just going to focus on denominators. I mean, the only way to get a common factor if you have 2 completely different variables is just to multiply them together. So our LCD for this one is just going to be 3x, okay? We're just multiplying those blue bubbles together. It's just 3x. And then we're going to do the same thing we've done every single time before, and we're going to multiply that 3x to the numerators, okay? We're going to multiply the 3x to the numerators. So we wind up with 12xy over 3 divided by 3xy, xz, not y, xz over x, okay? And now if we did this properly, again, the denominators are going to cancel. Now this time, the 12 divided by 3 leaves us with a 4 up top, right? So that 3 goes away. And we've got an x and an x here. So they cancel. So this leaves us with 4xy up top and 3z on bottom. Okay? 4xy up top and 3z on bottom. Any questions? Sweet. Okay, I'm going to start stealing some now from the homework, okay? Just randomly. Now, we haven't got to like some of the harder stuff, but yeah, let's look at number 2. I mean, we haven't made it far. Number 2, we've got 15 over 2x. This is on page 458, guys. This is the homework on page 458. 15 over 2x divided by 5 over 6x. Okay, so let's think about this. If I've got to get an LCD, whoa, no. Got a runaway Sharpie. I've got 2x and I've got 6x, okay? And I'm looking for common factors. Well, right away I can see x is in both of them. So I know my LCD is going to have x. And then I've got to think of the numbers, 2 and 6. Well, the least common multiple of 2 and 6 is 6, right? 6 is going to be divisible by 2, and it's also going to be divisible by 6. So my LCD for this is going to be 6x. I know 6x will cancel 2x, the x's will cancel, and 6 divided by 2 is 3, right? And I know 6x is going to cancel 6x because it's the same exact thing. Okay? So I'm going to multiply 6x on top and bottom. And then let's see what I get. I get 6 times 15. What is that, guys? Is that 90? X divided by 2x, right? Divided by 30x divided by 6x. Is that right? 6 times 15? That sounds right. Yep. Okay, and then stuff's going to cancel. If it doesn't cancel at this point, you did something wrong. You probably chose the wrong LCD. Okay, probably chose the wrong least common denominator if we don't cancel at this point. So 90 divided by 2 is going to give me 45. X divided by x cancels, right? 30 divided by 6 is 5, and the x's also cancel. So the only thing left in this numerator is 45, and the only thing left in the denominator is 5. So we wind up with 9. Hey, that's kind of neat. Okay? Kind of cool. You don't have to tell me. I know it's cool. Okay. I'm going to give you a few of these to work right now for a minute, just to make sure you've got it before we go on to the larger like binomial stuff. Okay, we've got to learn that this is the kind of basics. And really, it's not the basics. I think these are more complicated actually. But before we get to like just the monstrosity fractions that are humongous. Okay, so I'm going to give you a few of these real quick, and I just want you to attempt them. Let's say for A, we've got 3a over 25b squared divided by 9a over, actually that's a squared, guys, 9a squared over 5b. So that's the first one I want you to try. And let me find another one that I like that's kind of set up this way. Let's just try that one. Yeah, if we can do that one, we can do the other. So I'll go on to another example after that one. So try that one. Make sure we understand the concepts here. Okay, so first off, let's find the LCD. Now, look, we've got 25b squared, and we've got 5b, right? We're trying to think of something that divides into both of them. Well, if we look at the b's, it's got to be b squared because it's the larger of the two variables exponents. And then the 25 and the 5, well, the least common multiple will be 25. So it's actually that numerator that we're going to multiply on top and bottom's numerators. So let's do that. So 25b squared and 25b squared. So I wind up with 75ab squared over 25b squared divided by, now what the heck is 9 times 25? Man, is that 225? Am I right? Nope, nobody. Maybe. Where's my phone with the calculator? 9 times 25. Yeah, 225. I was right. Okay, 225 a squared b squared all over 5b, right? And now I've got to see what cancels and how this cancels. Okay, so I'm going to be very, careful here. I see the b squared cancels with the b squared there, right? 75 divided by 25 is 3, right? That's 3/4. So I'm left with 3a up top. So I'm going to write that down. 3a up top. Down here, though, 225 divided by 5 is going to give me 45. Okay? And then one of these b's cancels with one of the two b's up top. So therefore, I'm left with 45 a squared b. Okay, 45 a squared b. And then I'm not done here because I can keep going. Look, I got an a up top and an a squared on bottom. So one of these a's cancels with one of the a's, the a on top, I should say, cancels with one of the a's on bottom. So finally, last but not least, I'm left with 3. Oh, actually, 3 over 45 simplifies, doesn't it? Geez, this thing never ends. Yeah, 3 over 45, that's 1/15. Woo, man. So let's see here. So we wind up with 1 over 15ab. Man, that thing just kept going. That's a good example because it just kept going. Okay, 3 and 45. 45 divisible by 3. And there's a quick way to know that. It's because the 4 plus 5 is 9. 9 is divisible by 3. It's a quick way to know if something is divisible by 3, actually. If you add all the numbers up in the number, and it's divisible by 3, then the whole number is divisible by 3. Kind of goofy. If you want to know more about that later, ask me. If you're like, I don't know what he's talking about, I don't mind going over later. But let's go on now. Let's shift to binomials and kind of bigger looking, monstrous looking fractions. That doesn't mean they're harder though. So let's start with the really kind of easy one. It's actually number 6, x over x plus 2 divided by 2 over x plus 2. Now look, this is going to be the easiest, most simple one because these denominators are exactly the same, okay? But I want to show you the process with a really, really easy one first. Before I get going, the very first thing I'm going to do is if I have a binomial, trinomial, anything as a denominator or numerator, I'm going to put it in parentheses. It keeps it grouped together. And hopefully by now, it lets you know, hey, I can't cancel these x's because this is inside of a grouping. I've got to do this first before I can cancel anything, okay? So once you have something in a group, you can't just cancel it. The factor on top is x. The factor on bottom is x plus 2. Those are two different factors. They don't cancel. So for this one, the LCD is really simple, actually. Both the denominators are the exact same. So the LCD is going to be x plus 2, okay? It's going to be x plus 2. So I'm going to multiply x plus 2 on top and bottom, okay? So I multiplied x plus 2 on top and bottom. And then because this one is this simple, it just cancels. Now, so let's write it out. I'll add the additional step here. So we've got x times x plus 2 over x plus 2 divided by, so the big fraction, 2 times x plus 2 over x plus 2. Okay? And what happens, we're going back to what we did in 6.1 on Monday, right? If you look at this numerator, these two cancel because they're the exact same. And if you look at this denominator, these two cancel because they're exact same. So it leaves me with x over 2, right? That's it. Now, this is a very simple one, okay? They're going to be more complex than this. But we're going to, so that's one with a binomial. Let's look at one with like 4 different fractions in it, okay? Any questions, guys? I don't mind slowing down here. We have plenty of time. Even though we started 10 minutes late, like we're going to have plenty of time to cover this today. Okay. So let's look at one that just has just a bunch of fractions. Let's say we had number, like number 14. 2 over x squared plus 1 over x. I'm going to kind of write these kind of wide apart from each other because I know I'm going to be multiplying things with the fraction. This is number 14 in the book. 4 over x squared minus 14, 1 over x. It's not crazy that we have 4 fractions. This is more like the ones we did before, isn't it? This is a lot like that. I want you to try this one, okay? I want you to try this one. I realize you've got 4 denominators, and you just multiply the least common denominator from those 4 to all 4 of these numerators. So try that. I want you to try that. Well, of course, I'll go over it. I'll give you a few minutes. So LCD for this one. LCD for this one would be just x squared, right? Because it's the highest exponent. So try it from there. Okay, so I'm going to keep working if you're working. But I'm going to have to multiply x squared to all of these. So I wind up with 2x squared divided by x squared plus x squared over x squared all over 4x squared over x squared minus x squared over x, right? Wait. Do I have one of these wrong? Oh, this is just an x, isn't it? That's not an x squared. Let's act like that's not there. Okay, so then let's go to canceling. So I know that this entire x squared cancels with that x squared. One of these x's will cancel with that denominator x. Bottom, same thing, x squareds cancel. Now, only one of the x's cancels here because it's an x squared. So we wind up with 2 plus x in the numerator, right? 2 here. We only have an x left over from x squared over x, right there. And on the bottom left, we have 4 minus x here. Okay, what number was this? 14? Great. Now look, please do not tell me that the 2 and the 4 cancel to make 1/2, and this x and x cancels. Because remember, these are in groups. This is a factor. This is an entire factor like 7, and this is an entire factor like 8. I don't know what it actually is, okay? But they don't cancel because there's addition and subtraction going on, okay? That would be the most common mistake I would see on this test, okay? Would be you guys wanted to keep going because your brain thinks 2 over 4 and x over x simplifies, which it would if we didn't have subtraction or addition there, okay? It totally would. But this is an entire factor, and this is an entire factor. So we're done. This is it, okay? That is it. Guys, this isn't an easy question. Do you have any questions or issues or something not making sense? I'm going to pause it here for a minute. Drink of my Diet Mountain Dew. Okay, I'm going to assume we all get it. That's great. Okay, so let's go into one that does have the binomial thing going on. Okay, ooh, this one's kind of goofy. So I'm going to kind of modify this one. Jesus, they jump you off in the way deep end over here. Hold on. Let's look at one that's not so deep indie. I'll make one up. Let's say we've got 4 over x minus 2 divided by 5 over 3, okay? 4 over x minus 2 divided by 5 over 3. Now look, again, first things first, if I see an addition or subtraction inside of a numerator or denominator, I'm going to put it in parentheses, okay? So my LCD here is kind of easy to find because we have 2 totally different denominators. So we got an x minus 2 and a 3, right? We got a binomial and a number. So I'm going to keep these factored, okay? I'm not going to multiply them through. I'm going to say the LCD is 3 times x minus 2. Okay, I'm not going to distribute the 3 and say it's 3x minus 6. It makes it a lot harder, actually. I'm going to keep these factored, 3 times x minus 2. And then I'm going to multiply that on top and bottom. Okay? And then I'm going to cancel these out. Now, well, actually, let's just multiply them first. So 4 times 3 is 12. I'm not going to distribute here, x minus 2 over x minus 2. You see how that's going to cancel. And on the bottom, I wind up with 15 times x minus 2 over 3. We can see this is going to cancel with the 15. So let's do that. So the x minus 2 cancels, leaves me with 12. The 15 and the 3 cancel, that leaves me with 5, right? So I'm left with 12 in the numerator, right? Because these binomials cancel. And in the bottom, I'm left with 5 times x minus 2. I'm going to leave it like that. The 12 and 5 don't cancel, right? There's no common factors. So I'm going to leave it just like this in that factored form. Okay? Any questions about this before I keep going? Okay. Okay, cool. I'm just stealing another one then. This is number 18, okay? Now look, I'm going to write this bigger because we're going to have to write kind of all over it. 18 looks like this. 3 over x minus 4, I'm putting the parentheses there automatically, minus 2 over 4 minus x, all over 2 over x minus 4 minus 2 over x. I'm going to make sure I got that written down right. 3 over x minus 4 minus 2 over 4 minus x over 2 divided by x minus 4 minus 2 over x. Yeah. Okay. So first off, before I get going, if I look at these, do you see how this one almost matches, right? We can use that rule that I told you Dr. Martin Gay loves using, and it's if you've got the subtraction flipped, which we do, right, on both of those, you can just flip this around and factor out a negative, okay? Now, when you factor out a negative, there's already a minus here. It'll make this thing positive, okay? So I'm going to rewrite this whole thing. If you got a pencil, I'll just use a pencil. I'm going to rewrite this whole thing. So 3 over x minus 4. Now, look, I factor out a negative. These switch, and these two negatives make a positive. So it turns out to be plus 2 over x minus 4 all over 2 over x minus 4 minus 2 over x. Okay? I'm going to do that because now I only have two different factors going on, right? I've got x minus 4 in each one of these denominators, and I've got a lone x over here. If I didn't do that, this would be three different denominators. X minus 4 is here, and then 4 minus x and x here, okay? This will make it a lot easier to simplify. So let's see. My LCD for this one, I'm going to write it back over here. Well, I've got x minus 4 in each one of those, so I've got to have that. And then I've got an x down here, so I'm going to put that out front. I've got to have it as well, okay? And those are the only two denominators, really, right? Those are the only two distinct denominators, x minus 4 and x. So now I'm going to take this, and I've got to multiply it to all four numerators. Okay, let's see here. X times x minus 4. This is why I kind of spread it out. Okay. Now I'm going to multiply it out. You don't have to kind of put this next step in if you want to go through and just start canceling. You don't have to write this again. This is for me to kind of visually show you what's going on. But what's going on is in this first denominator, I've got 3x times x minus 4 all over x minus 4. Hey, that x minus 4 is going to cancel. Plus 2x times x minus 4 over x minus 4 all over 2x times x minus 4 over x minus 4 minus 2, oh, don't forget that x, times x minus 4, 2x times x minus 4 over x now, okay? Then I'm taking out my red marker, and I'm just going to start canceling every single denominator, right? This cancels with that one. This cancels with that one. X minus 4 and x minus 4 cancel. And then x and x cancel there, okay? So that leaves me with, I got a 3x, right? Plus 2x. So the first fraction is just 3x. Second fraction is just 2x, right? And the bottom left fraction is just 2x. Oh yeah, these were the same thing, right? Look, these two fractions were the same thing. And then lastly, though, I've got a minus here. The x is canceled, but I'm left with 2 times x minus 4. So that's going to take some cleaning up at this point to do, okay? What number did I say this was? Number 18, okay. Okay, I see how we're going to get that. Okay, so now we've got to clean this up. I'm going to add the numerator because I can add 3x and 2x. Distribute the negative 2, though, so I got to come back down here. So on the top, I get 5x. And on the bottom, I get 2x minus 2x plus 8, right? So the 2x here minus 2x plus 8, because negative 2 times negative 4. Okay, 2x minus 2x is 0. That cancels. So we wind up with 5x over 8. Hey, look, and this is the crazy part of these. This whole thing that we started with, this craziness, is really just 5x over 8. Once you simplify it, it gets down into the basic fraction of just 5x over 8. Okay? Questions on 5x over 8? That's a lot of steps. I mean, we've got really one. I'm not going to count those steps because you could have canceled it all from here. So 1, 2, 3. We had really 3 steps going on, kind of 4 steps going on, actually. 1, 2, 3, 4. Yeah, 4 steps. Okay, man, you guys just really, I must be the best instructor on how to teach simplifying complex fractions that's out there. I will take that as a compliment that you have no questions to ask. Okay. I've taught this enough. I know you're not all getting this. Okay. And I understand this is not easy. Okay. This is not the easiest thing to do. And it really just takes time and practice. So let's move on to one where we're going to have to do a little different finagling, I guess, because some of these we have to factor first. Oh, excuse me. Let's look at one where we have to really kind of see if we can factor and then go forward. This is 26 on page 459. 7y over x squared plus xy over y squared over x squared. Okay. Got an ant going on here. You see that? Okay. So before we get started on this, I mean, again, I'm going to put parentheses. There's only 2 denominators here, which is nice, but it gets a little tricky. And notice in that parentheses, I can factor an x out. So before I get rocking and rolling, I'm going to factor the x out to see what's left over. I'm going to be left with x plus y, right, over y squared over x squared. Okay, so really I have 3 different factors. I've got the x, the y, x plus y, and the y squared. Okay, so if I'm looking for LCD here, it's a little different. If I look at the x's, remember with the x, if it's the same variable, we just go with the higher exponent. So I know I need an x squared, right? I got an x and an x squared. I know I'm going to need the x squared because it's a higher variable. It's going to cancel out the x squared. It'll also cancel out that x. It'll leave me with an x on top. Now I also need an x plus y, right? Because it's another factor. So my LCD is looking like that now. So I'm going to do the same thing we've been doing every single time. I'm going to multiply that to both of these numerators. Only 2 numerators this time. Okay. So I'm gonna write this together now. It's gonna look kind of crazy, a little complex, one might say. So I've got 7y times x squared times x plus y. That's the numerator's numerator, right? Divided by x times x plus y. That's my numerator fraction. And then big fraction bar, I've got y squared times x squared times x plus y over x squared, right? That's the denominator fraction. That's here, okay? I'm going to be careful. There's a lot going on here, so I've got to make sure I cancel accordingly. Okay, let's see here. This x would cancel with one of those x's, right? And this x plus y would cancel with that x plus y. This x squared cancels completely with that x squared. So in the numerator, I'm left. Now I'm going to write this alphabetically because it's just a thing that we do. So instead of saying yx, you would say xy, right? So in the numerator, the only thing we're left with is 7xy, right? Everything cancels except one of the x's, because that one had an x down here, and there's 2 x's up here, and then the y and the 7 that we started with. In the denominator, though, we're left with y squared times x plus y, right? Y squared left with x plus y. Now, hopefully, your brain's going, hey, Mr. Shirley, there's repeating y variables, right? We've got a y up here. We've got a y squared down here. We can keep going with this. So this y can go away with one of the y's in the bottom. So that leaves me with 7x over y times x plus y. And now look, we can cancel anything else. We have 4 factors here. None of them are the same. A 7, an x, a y, and an x plus y. They're all different, so there's no way we could cancel anything, okay? We are done. Question. Comments, concerns. Okay. Let's see. I'm gonna try to dig some up that looks scary. Ooh, yeah. Ooh, man. Let's look at 34. That looks rough. Actually, before we do 34, let's do 32. That'll kind of lead us into 34. 32 is x minus 2 over x squared minus 9. So I'm going to put parentheses right off the bat. Divided by, we've got 1 plus 1 over x minus 3. Ooh. Okay, this is number 32 on page 459. 32 on page 459. Hold on a second. The internet issues I'm having before, I'm getting an email about it. Hold on. Okay, so before I get started here, you have to notice this, okay? You've got to think, hey, can I factor any of my denominators? And that x squared minus 9 is a difference of squares. So that can be written, x squared minus 9 is x minus 3, x plus 3, right? And then, just like before, this 1 is just hanging out there. I'm going to think of it as 1 over 1. I'm going to leave big gaps between these because we might have a really big least common denominator. I'm going to predict that. Okay, because we've got these 2 factors up here. Okay, so my LCD this time, I'm going to try to write it over here. Look, I've got x minus 3, which matches here, which is nice. I don't have to do that twice. X plus 3 and 1. 1 doesn't matter, right? Anything times 1 is itself. So I've got to multiply the distinct factors in those blue boxes. Well, you can write 1 if you want. It doesn't matter. X minus 3, I've only got to write once because it's distinct. And then x plus 3. So this really is my common factor. X minus 3 times x plus 3. So I'm going to take that and I'm going to multiply it into all the numerators. That's why I left that gap there. Okay, I've got to take x minus 3, x plus 3, and multiply it to all the numerators. So what happens, now if you want to just cancel from here, that's fine. But what happens is that numerator turns into x minus 2 times x plus 3 times x minus 3. I don't know why I changed the order. That was goofy of me. Over x minus 3 times x plus 3. That's the numerator, right? Divided by, now this first fraction now just becomes x minus 3 times x plus 3 over 1, right? Plus, this other fraction is x minus 3, x plus 3, all over x minus 3, okay? Man, that's a lot going on. And one little goofy mistake and we can get it all wrong, right? That's the tough part on these two. Okay, so let's go to canceling now. X minus 3 cancels with that x minus 3. X plus 3 cancels with that x plus 3. Nothing's going to cancel here, right? Because you're dividing by 1. But that's fine because there's no fraction in the fraction. And then the x minus 3 cancels here. Okay, so let's see what we're left with. We're left with x minus 2 on top, right? All of this went away except for that little factor. X minus 3 times x plus 3, that's here, plus x plus 3, okay? Questions so far? Okay, so we've got to FOIL this out and then add it with this x plus 3, right? We're going to focus on this denominator now. So numerator's fine, it can stay put. If you FOIL this out, you get x squared minus 9. It's difference of squares, right? X squared minus 9 would factor into x plus 3, x minus 3. And now you've got to add that with x plus 3. So this, if you FOIL it out, becomes x squared minus 9. Okay. Then we've got to add these together. So this winds up being x squared plus x minus 9 plus 6. Or plus 3 is a negative 6. Holy cow, this question's not done. This is crazy. This is a never-ending question. Any questions to that point? Okay. I can factor that numerator, or the denominator, I'm sorry. I can factor that denominator. Now, I should have put parentheses around the numerator. This denominator factors into x plus 3, x minus 2, right? Do you guys see that? Because multiply, x squared by itself, so we can do the quick factoring. And then we have 3 times negative 2 is negative 6. And then if you add 3 minus 2, you get the positive 1. And so look, these cancel. And now we are finally at our final answer. Now, this is like the last question. Okay, guys, so don't get too freaked out. It's the last question in the homework. Okay, that's the challenge. I would say that the challenge one for you guys is going to be, because I'm going to do the odds. Like 33 is the challenge question. 31 and 33 will be quite challenging in the homework. Okay. Any questions today? Any questions about anything? Hold on. So for homework, this is on page 458, 1 through 33 odd. Okay. Page 458, 1 through 33 odd. Okay, so hold up. I've got to make a little bit of an announcement. Let me move over to my other video. Hey, there I am. Okay, so I'm going to start transitioning back to the classroom, and I'm going to give you some pros and cons to that and some rules. Okay, first off, I can only have 8 in the classroom. That's the main rule. So I've got to determine a way to divide you guys up if you want to come to the classroom. So first off, I've got to decide to find out who wants to be in class and who doesn't. I don't care either way, but I'll send out a questionnaire, kind of like I did at the beginning of the semester with that Google questionnaire. Actually, let me stop. No, because the students that are watching this later on need to see it. So fill that out for me. So that way it'll just let me know who wants to be in class and who doesn't, and how I need to divide up the classroom. So the main thing, number 1, is if you're in the classroom, you have to wear a mask. Number 2 is you have to stay separate. Now, our classroom we're using down there has like separate tables, so it's kind of easy to stay separate. That's not going to be a big deal. So wear a mask, stay separate, and realize all I'm going to do is take this kind of setup and I'm going to put it down into that classroom. So it's going to look, to stay consistent for what we've been doing for over half of this semester, it's going to look very similar to what you're doing now. I just have to figure out the Wi-Fi situation. That's what was happening this morning. I was trying to figure out how to move this kind of setup with a laptop actually down to that classroom so I could just teach the same way. So in a way, the product's the same, but if you want to be in front of me, that's fine. I don't care if you want to sit in front of me. It's just you got to stay 6 foot away from me and you have to wear a mask. Okay. I'm not like crazy conspiracy theory on this coronavirus stuff, but I don't want to get coronavirus. My kids have too much crap going on and I want to be a part of it. Okay. So I don't want to be sitting at home for 2 weeks, not being able to participate and go to my kids' cross country meets and my kids' band concerts, because that's what I love the most about being a parent. Okay. It's going to really piss me off if I get this COVID from it. I want you to know that. Okay. So I will get you the information. I'll get you the questionnaire. The main part is to be as safe as we can. And just give me a few days. So I probably won't start till next week because I've got to find a good way of transitioning over down there and not just kind of a knee-jerk reaction. So just FYI, look for that questionnaire. I'll probably email it to you instead of just putting in an announcement. So I'll email it through Blackboard. So just check. You should be checking your ASU Mountain Home email consistently daily. Okay, so have that filled out, especially if you want to be in the seated. If you want to come in and just be seated, that's fine. Just fill it out. It's not a big deal. Okay, so are there any questions though? And I really would appreciate questions because I don't know what you guys' questions would be from a student side on transitioning back to the classroom. I'm still going to record the lectures. So if you don't want to show up, that's fine. So you guys that are watching this video like later tonight, that's fine. It should look similar to what we've been doing so far. Okay. But are there any questions? And I'd kind of appreciate them actually if you can think of any from the student side. Make sense? Okay. So I will see you all tomorrow morning. And then I've got the test. I've already made the test. So hopefully we can get done a little early. Tomorrow we're going to go over solving with fractions, like equations that have rational expressions, which is honestly the easiest of these 3 sections on the test. Okay. So I think we can probably get done in maybe like 45 minutes, 50 minutes, and then have another, 25 minutes or so, or 30 minutes to review for the test, which would be great for this section. In the past, this is one of the harder tests. I've never given it, through Blackboard where you can kind of use your notes and stuff. I don't know if it'll help, but we'll see. It's just one of the harder ones. So I think anytime you can kind of review a little more, I would suggest getting as much homework done tonight. That way, when we get to the review, I can, answer some good questions that maybe you guys are kind of stuck on after you've hit the homework. Okay. Okay, great. I'll see you guys tomorrow. Have a great day. I'll stay on here for a little bit, guys, if you have any questions.